All right, so these are the word problem assignments. Or not assignments, this is the word problem assignment. We have 4 today. Right there. All exponential stuff. All right, the expression that gives the amount of money in thousands of dollars in Carter's savings account 2 years after he opened it. What does the 1.01 represent? Who remembers that from 2 days ago? It's right there. What'd you say? Yeah, right. And so it says it's in thousands of dollars, right? So if I take that times 1,000, guess what it is? Right there. Okay. So that's the amount he started with. What if they asked about this? This 1.005. Well, 1.005 tells us how much it's increasing each year. Okay, let's do another one. 1.45 is what they're asking about now. The expression models the number of billions of genetic sequence bases available in the public database. Project T years since 2002. What does 1.45 mean? Yeah, it's not the time. The number of bases in the database is multiplied by 1.45 each year? Yes. This would be if there was 1.45 right here instead. Okay, let's move on. The graphs are super simple, but you're going to want to watch this. All right, choose the graph of the function. First thing is this is the starting point. So when I say starting point, pretend like the time is at 0 or the x-axis is at 0. That's the same thing as what you would know as the y-intercept. Okay, so the y-intercept is 5. A works, B doesn't, C doesn't. None of them have a y-intercept of 5, so this has to be it. What does the 2 tell us? Right. Yeah, so you can call it the growth rate if you wanted. And what that would mean is if I go over 1 unit, this thing goes up double. So if I went from 0 over to 1, it went from 5 up to 10. Follow that, Mace? Okay, let's do another one. Choose one answer. Well, first of all, the starting point is 5. How much is this thing growing? Well, if I go over 1 unit, it goes up to 10, right? So from 5 to 10 means a multiplication of 2. It's the same graph we just had. Yeah? Okay. Let's do one more. Starts at 2. Let's go through. Oh, look, only C is like that. It's not so bad, right? Okay, let's do another one. Let's keep going. I like our momentum that we have now. Lots of momentum. Are you ready? Okay, Alicia has invented a new app that 2 companies are interested in purchasing for a 2-year contract. Company A is offering 10 grand for the first month and will increase that amount each of the following month by $5,000. That's like a line, isn't it? If you start at 10 grand and if it goes up the same amount each time, it'll be like that, right? Company B is offering $500 for the first month and will double their payment each of the following month. For which monthly payment will Company B's payment first exceed Company A's payment? So at some point in time, this is going to pay off, isn't it? Because it'll be 500, and then it's going to double. What's the next number going to be? 1,000. And next number? and then, okay, and then 16, and then 128, right? So let's do that same thing with company A up here. Company A is merely adding 5,000 each time. So if it starts at 10, what's the next one? 15. Now what we're doing here is we're comparing month 1 versus month 1, month 2 versus month 2, and we're going to see when does company B turn into a higher number. You understand the problem now? Okay, let's keep going. This is 20. It's 20,000. This is 25. This is 30. And now we're going to start row 2. 35, and then 40, and then 45. Bingo. Right here. That's after 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. Right? On month 8, company B pays more, doesn't it? You ever heard this? I guess it's a riddle. It's really a math problem. Give you $1 million on the first day of the month, or I could give you a penny and double it every day of the month. Which one would you take? You ever heard that? Okay, we'll talk about it in a second. Hang on. So it should be month 8. There we go. How is it 8? So up here, this was month 1, 2, 3, 4, 5, 6, 7, and 8, right? Yeah, that's 4,000. My units weren't real good. All right, I should have just wrote 4. Sorry, it was confusing. Anyway, let's do one more. 2 cities are building bicycle paths. We've got 5 kilometers. Anyway, this one's about the same. We'll move on from that. I think you get the idea. Okay, let's do some decay. Sorry, Trev. Is this growth or decay? Well, here's where you have to look. This is the rate, growth rate, right here. Is that number, when you multiply it by something, will that make the next number smaller or larger? All right, so if I take, for example, 2,000, and I take it times 2 ninths, I just made up the number 2,000. What's the next number going to be? Will it be smaller or larger? It'll be smaller because 2 ninths is smaller than, it's smaller than 1. Right? It's a fraction where the top number, the numerator, is smaller than the bottom number. So that's decay. It is shrinking, or it's losing value. It says, what is the shape of the graph of the function? Well, first of all, what's the growth rate? Is it growth or decay? It's decay. So what should be happening? A or B? B. The graph should be sloped downwards like that. Growth or decay? Growth. Our growth factor here is bigger than 1. All right. That's all.